So continuing chapter 16, I want to spend a little time talking about what I call polyprotic acids and some interesting things to consider with polyprotics. Polyprotics, again, have more than one proton, so you will see them listed with H with a 2 or a 3 in front of it to show that you have more than one proton. We discussed this really early on. I kind of showed you some of these equations before. Realize that these are, each hydrogen is independent of each other, meaning they are going to come off one at a time. So if I take the example of phosphoric acid, the first H that comes off is going to produce H2PO4 dihydrogen phosphate with a negative charge. And then that's going to release an H, and then that's going to release an H. So you get a total of 3 H's that come off in that acid. Well, each H that comes off is going to have its own Ka. So if you want to write it as Ka1, Ka2, and Ka3, Ka1 is always assumed to be the first hydrogen that comes off. Well, if you were to look up these values for H3O plus releasing its first, it's 10 to the negative third. H2PO4 minus is 10 to the negative eighth. And then HPO4 2 minus is 10 to the negative 13th. So in reality, most of your polyprotics, your pH is going to be driven by the Ka1, meaning whatever this number happens to be, that's going to be how much H plus you can calculate is being formed. Because yes, H plus is formed here and here, but the quantities are going to be so low that the pH is really going to be driven by that. Now, the reason I'm bringing that up is we have a special case of sulfuric acid. Okay, sulfuric acid is very unusual because of the fact that it has 2 hydrogens attached, and the first hydrogen that comes off is what we call a strong acid. Okay, so that arrow is only pointing in one direction, and that's going to be key and something we're going to talk about in the next video having to do with salts. So H2SO4, that first H that comes off, you can't find a Ka for it, okay, when you look it up on tables. So it is the strong component in this diprotic acid. But then the HSO4 minus, that H does come off, but that Ka is considered to be a weak acid. But it's a 10 to the negative 2. So that's a pretty large quantity of H plus that comes off, but it's still considered weak. So for a calculation with H2SO4, you're going to have to do 2 things. One, you're going to have to add the H plus from the first reaction, and then you're going to calculate the H plus from the second reaction using the Ka given. So I'm going to show you that calculation because it is quite unusual, and it is unique to H2SO4. It is unique to H2SO4. So what is the pH of a 0.1 molar H2SO4? If my Ka2, and again, we still call this a 2 because it's the second hydrogen come off, is 1.2 times 10 to the negative second. So if I look at H2SO4, okay, that first H that comes off, okay, is strong. So I draw the arrow pointing in one direction. So if I have a 0.1 molar concentration of H2SO4, I have a 0.1 molar of H plus and 0.1 molar of the HSO4, okay? But I take HSO4 minus, hydrogen sulfate, okay? That's at equilibrium with H plus and SO4 2 minus. So the second H that comes off. So this is an equilibrium. Well, how much HSO4 do I start off with? We'll go back to the first equation here. This is 0.1 molar of that. What is my initial concentration of the H plus is going to be the 0.1 molar here. So again, this is not starting at zeros. This is what makes it unique. And then SO4 2 minus, I have none of that at the start, okay? So this goes down by X, this goes up by X, up by X. So that's exactly the same. But what is different is the fact that the H plus, you have 0.1 plus X. So the second H that comes off, we have to account for that. So I have a Ka2 here, okay? I'm looking only at the second reaction because that's the one that I have to consider in terms of the calculation for H plus. So what goes on the bottom here is the HSO4 minus. That goes on the bottom, and the H plus and the sulfate goes on the top. So what goes on the top is 0.1 plus X times X, so it's not an X squared on the top, and this is 0.1 minus X, okay? And this is equal to your Ka2, which is 1.2 times 10 to the negative second. Well, fortunately or unfortunately, that 10 to the negative 2 is pretty significant. So I can't cross out this X on the bottom, okay? So instead, you're gonna have to do the quadratic formula. So see if you can solve for X using the quadratic using your calculator, and then I will come back and show you the answer. All right, so you should have ended up with X being 0.0098, 0.0098. So again, check with your friends if you don't know how to do the quadratic on your calculator, graph it, whatever you do. But that's how you solve the quadratic, again, where you can't cancel out the X. So let me finish up this problem talking about the ions we have in there, and also calculate the pH and kind of show you why, what you could consider with these types of problems. So what is the H plus? The H plus is going to be 0.1 plus 0.0098 in terms of concentration. So it comes out to be 0.11 molarity as my concentration of H plus. What's my HSO4 minus? So that means over here, so that's going to be 0.1 minus X. So that's going to be 0.1 minus 0.0098. So that's going to be approximately 0.09 molarity. And SO4 is the easy one. That's just X. All right. So what is my pH going to be? Well, if I take the negative log of the 0.11, my pH comes out to be about 0.96, okay, which is what they were asking for in the problem. Now, let's have a little discussion here. If I were to take the pH of 0.1, which is the concentration that was given in the problem, okay, if I just take the pH of 0.1, I get 1 as my pH. Is 1 all that different from 0.96? No, I know some of you with math brains have problems with this, but realize that yes, a more correct answer is the 0.96. Depending upon the concentrations, again, if this concentration was 0.01 molar, yeah, then you really will see a different in terms of your pH value. But again, I wanted to show you something with using the quadratic so that you are confident that what we've been doing along the way has been okay. But in reality, with H2SO4, depending upon the concentration, you might have to consider using the quadratic. But if your concentration is like 0.5 molar, just take the negative log of it, and that's going to be your pH. Okay.